Hi children, welcome to the session. So this is Aruna, your maths teacher from Bharathidhasanar Matric, Higher Secondary School, Arakkonam. And today we are going to see 8th standard maths, the 3rd chapter, which is squares and square roots. First we will discuss about squares. So what is square and what is the square number and what is perfect square also. Square is nothing but a number which is multiplied by itself is called the square of that number. See, the product of a number multiplied by itself is the square of that number. For example, when you are going to multiply a number like 3, product is into the number which is need to multiply by itself, that is 3 by 3, which gives 3 3s are 9. So 9 is a perfect square. A number which is multiplied by itself is called the square of that number. Where we are using squares in our life. So, to find the area of a square field, for example, the square will be like this, all the four sides are equal or called squares na. So, to find the area of the square, so the formula to find the area of the square is a square, which is nothing but a into a. Here the number which repeats 2 times is the a square. To find the area of the square field or to calculate the area of the square shaped flats, everything we are using squares in our day to day life, right. See, the not only for 3, we can use from 1 to till the end of the numbers, we can find the square numbers like 1 square. 1 square is nothing but 1 into 1, 1 ones are 1. Then what is 2 into 2, 2 2s are 4 and 3 3s are 9. Likewise, we can find 4 4s are 16. So, this 1, 4, 9, 16 and then 5 5s are is 25 and till it will be going on. These numbers are called perfect squares. These numbers are called perfect squares. When the number is multiplied by itself and the product what we are getting is the square of that number, the numbers are called perfect squares. Is it clear? So, we can find the perfect squares for the least numbers like 25. If I ask you, you can say it is a perfect square because we can express in the product of 5 5s are, right. But if I am going to give any large number using 1 6 3 4, can we say this is a perfect square or not? No. So, we are going to use the properties to find the perfect squares. See, the first property is properties of perfect squares we are going to see. The first one is perfect squares will end in 0, 1, 4, 5, 6 and 9 only. The number which ends by 0, 1, 4, 5, 6 or 9, the numbers are may be a perfect square. It will not be necessary to be as a perfect square. It may be a perfect square. And the number which ends by 2, 3, 7 or 8 will not be a perfect square. Surely it will not be a perfect square. For example, if I give you 2, 7, 6, 3. Whether it is a perfect square, by seeing this number, we can say it is perfect square or not. How? See, the number which ends by 3. Here they have given 2, 3, 7 or 8 will not be a perfect square. So, the number which ends by 3 is not a perfect square. For then the number which ends by 0, 1, 4, 5, 6 or 9 is a perfect square. It may be a perfect square. So, by seeing the number we can say it may be a perfect square and which will not be a perfect square. And how to find the number which ends by this will be a perfect square, we will see in the exercise. And the next property is the square of a negative number is always positive. So, the negative number, here the negative number may be a whole number or an integer or a decimal number or a rational number, whatever number it may be. If it is a negative number, the square of that number will be what? Always positive. For example, we can see minus 3 square. Minus 3 square. Here minus 3 square I can express as minus 3 into minus 3, right. So, minus into minus it will be plus, and what is 3 3s are? 3 3s are 9. Is it clear? So, negative square of a negative number is, what is this? The answer is positive. Not only for the whole number or an integer, we can find for the decimal number or a rational number also. For example, minus 2 by 5 whole square. It is a negative rational number. If we find the square of the negative rational number, the answer will be always positive. Minus 2 by 5 into minus 2 by 5. See, minus into minus it is plus, and 2 2s are 4 by 5 5s are 25. So, the answer, the square of the negative rational number we got as a positive number. So, perfect squares is always positive, right. The next property is, the square of an even number is even and the square of an odd number is odd. So, when you are going to square a even number, the answer will be even, and for an odd number if you square, the answer will be odd. See, we will used to see in the example with even number. So, even number means the number which ends by 0, 2, 4, 6 and 8. The number which ends by 0, 2, 4, 6 and 8 are even numbers, and the numbers which ends by 1, 3, 5, 7 and 9 are odd numbers. So, using these numbers, even numbers and odd numbers, we will see with examples to square that. See, first we will take a even number which is 6 square. If I square 6 square, what will be the answer? 6 into 6. What is 6 6 are? 6 6 are 36. The number ends by 6, which is an even number, right. So, square of an even number is always even, and square of an odd number we will go. See, 9 square, 9 is an odd number. If I square an odd number, what will be the answer? See, 9 square is 9 into 9. 9 9s are, what 9 9s are? 9 9s are 81. See here, it ends by 1. 1 is also an odd number. So, square of an odd number is always odd. Is it clear? In 1 marks, whenever they ask you to give the answer, the square of an odd number is dash, we can say it is odd. Without finding with the example, we can give the answer directly when the square of an even number is even, right. The next one, see, using these properties, we are going to see few example sums. Find the squares of the following numbers in decimals and as well as a rational number also. Here the examples is given. We are going to square the number. So, what is the meaning of square? We have seen the number which is multiplied by itself, right. So, here I am going to multiply this number, that is 1.2, the whole square we are going to find. So, the whole square is 2 times we need to write, which is 1.2 into 1.2. So, here it is 12 and 12 without decimal point, right. So, what is 12 12s are? First we will multiply the number and then we can keep the decimal point. So, 12 12s are 144, right, and now we need to keep a decimal point here after one place and here also after one place. So, totally after 2 places we want to keep a decimal point in the answer. From the right side we need to move 2 places towards left side, right. So, from the right side 1, 2 and then keep your point. So, the answer is 1.44. Is it clear how to square a decimal number? And minus 26 by 15 is a negative rational number. So, when we square a negative number, what will be the answer? Answer will be always, yes, answer will be always positive. Very good. So, minus 26 by 15, the whole square equal to, the number need to multiply by itself now. 2 times we are going to write, which is minus 26 by 15 into minus 26 by 15. So, the next step will be minus into minus, it will be plus, and multiply the numerator with numerator. 26 into 26, what will be the answer? 26 into 26. 6 6 are 36. 6 remaining 3 and 6 2s are 12. 12 plus 3 13, 14, 15. So 1 5 6 and then 2 6 are 12. 2 remaining is 1. Again 2 2s are 4. 4 plus 1 is 5. So 6 7, 5 plus 1 is 6. So the answer is 676 by the denominator. What is the denominator? 15 into 15. 15 15s are. 15 15s are. If you want, you can multiply, children. 15 into 15. 5 5s are 25. 5 1s are 5. 5 plus 2 is 7. 1 5s are 5. 1 1s are 1. Add this 5. 7 plus 5 is 12. 2 remaining will be 1. 1 plus 1 is 2. So 15 15s are 225. If you know the answer, 15 15s are, directly you can write 225. Is it clear how to square a decimal number and a rational number? And the next Roman is, check if the following numbers are perfect squares. I told you when it will be a perfect square, right? The number which ends by 2, 3, 7 and 8 or a perfect square? No, the number which ends by 2, 3, 7, 8 will not be a perfect square. Here see the number which ends by 1. So it may be a perfect square. So how to check whether 9801 is a perfect square or not? So by using prime factorization method. We know how to find the prime factorization method, right? We will use only prime numbers in that. So what are all prime numbers? The number which is divisible by 1 and the number itself is called the prime number. So 2, 3, 5, 7, 11, these are all the numbers or prime numbers. So we are going to use the prime numbers to find the answer here. See, 9801. First I am going to find the prime factorization of this number. The number which ends by 1 will not be divisible in 2, right? So the next is, we are going to use 3 table here. Yes, take 3. The first number is 9. How many times 9 is divisible in this 3? 3 3s are, yes, 3 3s are 9. There is no remaining na. The next number is 8. How many times in 3 table? 3? Yes, 3 2s are 6. 3 2s are 6. But number is here 8 na. So 3 2s are 6. 6 after 7, 8. Remaining is what? 2. So 2 will be here, which is 20. So now 20 we need to see how many times in 3 table. Right? How many times we can get 20 in 3 table? Yes, Vignesh, tell me how many times? 3? 6 are 18. Yes, very good. 18 after 19, 20. So again the remaining is 2. Now the next number 2, 1, 21. Yes, Anjana, how many times 21 is divisible in 3? 3 7s are 21. Very good. Now again we are going to take, the number is odd number na. So we are going to use 3 table again. Now 3 how many times in 3? 3 1s are 3. Right? The next number is 2. Whether 2 is divisible in 3? No. Because 2 is smaller than 3. When the number is not divisible, what we need to do? We need to put 0 here, then only we can join this next number, which is 26. Yes, Deepak, how many times 26 in 3 table? 3 8s are 24. 24 after 25, 26. 2 is remaining, which is 27. Now, how many times 27 in 3 table? 3 9s are 27. Yes, again we are going to take 3 table here because the number is odd number. If it is even number, it will be divisible in 2. Or else we want to check in 3 and then 5, it will be going on with the prime numbers. So, we will try with 3 now. First we will take 10. How many times 10 is divisible in 3? 3 3s are 9. So 3 3s are 9. 9 after 10, 1 is remaining. So if 1 is here, then it will become as 18. How many times 18 in 3 table? 3 6 are 18 and 3 3s are 9. Very good. Again we can use 3 table here. 3 1s are 3 2s are 6, 3 1s are 3. Now 121. See, which will not be divisible in 3 table here. 121. See, if you take 121 and if you divide in 3 table, 3 4s are 12 you will get. What about this 1? 121 is not divisible in 3 table, or else you can see the sum of the numbers. 1 plus 2, 3. 3 plus 1, 4. 4 is not divisible in 3 table. So 121 is also not divisible in 3 table. But 121 is a square of 11. 11 square, which is 11 11s are 121. Again we can take 11. 11 ones are 11. Okay. Now we can make the answer like 9801 equal to, see the numbers here, 3 3 3 3. 4 times is there na? We'll use to write 3 into 3 into 3 into 3 into, then the next two numbers are 11 into 11. Now pair the numbers here. So 3 square into 11 square. We can write like this, 11 into 11 as 11 square. Now I can write this number as 3 into 11 the whole square. Okay. Now I can product this numbers which is in the bracket, that is 3 3s are 9. 9 11s are 99. So 99 square. The value 9801 is the 99 square value. Therefore 9801 is a perfect square. Is it clear how to find the perfect square of a number? See the second question, 6287. The number ends by 7. Whether it is a perfect square? No. The number which ends by 2, 3, 7, 8 is not a perfect square. So 6287 is not a perfect square. So the number which ends by 0, 1, 4, 5, 6 and 9 may be a perfect square. If it is a perfect square or not, by using prime factorization we can find the answer like this, right? The next we are going to see the next property, which is for any two consecutive natural numbers, that is consecutive natural numbers is continuous number. The number may be n and n plus 1. We have n plus 1 square minus n square equal to n plus 1 plus n. First we will consider n as a natural number, which is n equal to, if n value is 6. What is n plus 1? Here they have given n plus 1 na. N plus 1 equal to 6 plus 1, which is 7. So n and n plus 1 is 6 and 7, which is the consecutive natural numbers. N plus 1 square minus n square. When the question is given like this, that is, instead of n plus 1, we are going to take 7. So 7 square minus n square. N is what? 6. So 6 square. If your question is given like this, find the value of 7 square minus 6 square using the property. So no need to square the number and to find the difference of that number. Directly we can use the property which is given here, n plus 1 plus n. What is the value of n plus 1? N plus 1 is 7 plus, what is n? N value is 6. So just by adding this 2, 7 plus 6 is 13. Directly we can give the answer using the property, children. See, 7 square minus 6 square, you don't want to square the number and to find the difference. Directly we can write 7 plus 6 which is 13. We can check the answer now. What is 7 square? 49. What is 6 square? 6 square is 36. Find the difference. 9 minus 6, 3. 4 minus 3 is 1. We got 13 as the answer now. So, using the property, it will be easy to solve the answers. Using this property, we will see the exercise problem now. So, using the properties of squares, find the values of the following. See, 22 square minus 21 square. See, this property is applicable only for the consecutive numbers, not for 21 square minus 19 square like that. Only the consecutive numbers, continuous numbers should be there, right? So, 22 square minus 21 square is given. Then, what is the property we have seen here? So, which is 22 plus 21. If you find the sum of these two, that will be the answer of this 22 square minus 21 square. So, what will be the answer? 22 plus 21. 2 plus 1 is 3. 2 plus 2 is 4. So, the answer is 43. Directly we can give the answer like this. Without finding the square and difference of that number, we can find the answer simply using the properties. Can you answer this? 100 square minus 99 square. So, what will be the answer for this? Yes, what I need to write now? First, n plus 1 value, which is 100 plus. Then n value, what is n? 99, very good. Now, 100 plus 99 is 199. So, it will be easy to solve this using the properties, right? So far, we have seen 3 to 4 properties of the squares. In the next section, we will see about the square roots and squares, how many properties are left, right. Okay. So, using the study material and question bank, we can solve the exercise problems too. See, your question bank will be like this, which is given in your description box, right. This is the question bank which is given squares and square root, the third chapter. See, find the squares. Here they have given 12 questions. I taught you only few sums, 1 or 2 questions. So, using this you can solve the remaining problems too in the same way, right. The next, see, check if the following numbers are perfect squares. They have given like this. So, for 9801 I have solved, 6287 I taught you, right. So, remaining problems which is left 10 problems, you can find the answers. Likewise, question bank is given to you. And then study material. See, the study material also attached in the description box like this. The study material is nothing but all the properties which is given here, and the exercise problems also solved like this. After you are using the question bank, you will solve the answers, and you can go through this, and with the question and answer is here now, you can check the answers, whatever you find is correct or wrong. And then you have one more thing, which is self-assessment. Self-assessment is nothing but to write the test. After you are finishing the subject note using question bank and study material, you can write the test using this question paper, which is given only for 15 marks, children. So, if you return the test using this question paper, you can evaluate how much you have understood. Thank you, children.